Alright, here's a video 9.4, molarity. The equation for molarity is the following. Molarity is equal to moles of solute divided by liters of your solution / your solvent. Now, what I mean by of solution / solvent, generally it's going to be your solvent. Technically it's of your solution, but generally, especially for this class, it's just going to be of your solvent. And so, which is the thing you're dissolving. Normally that's water, okay, in an equation or in a problem. And so this is the formula, but normally we write it out like this. Molarity is equal to moles divided by liters. And the units here are moles per liter, or just capital M. Now, again, problem solving is always best understood by doing problems. And so, and a note on that, not watching someone else do problems, but doing the problems yourself. And then, you can watch me later to like confirm, right? But please do your problems yourself. That's scientifically, every single study shows that that's the best way to do things. I know it's hard though, right? And the process of struggle is difficult, but let's do some problems. Do some problems yourself too, and this will make a lot more sense. And so here's your practice problems. What is the molarity of a solution with 0.35 moles of NaOH and 500 milliliters of water solvent? So how would we do this? Well, molarity is equal to moles divided by liters. Let's identify what we have. We have 0.35 moles, and we have 500 milliliters of water solvent. As I mentioned to you here, right, this liters of solution / solvent. Normally it's going to be solvent, and so here it is solvent. And it's asking us for what is the molarity. So we're going to solve for this by plugging in to here and here. Now do note, here we have liters and we have milliliters here. That's one of the tricky things. You have to make sure that you have your liters of solution / solvent in liters always, okay? And so 500 milliliters, remember 1,000 milliliters are equal to 1 liter. And so therefore here, you could do dimensional analysis, or you could do it in your head, and you know that this is therefore 0.5 liters. Molarity, therefore, is equal to 0.35 moles of NaOH over 0.5 liters. We then put that into our calculator, 0.35 divided by 0.5, and you get 0.7 moles of NaOH per liters of NaOH, or 0.7 molarity NaOH. Right? So those are your answers. You see, it's just simple plug and chug. It's algebra. It's algebra 1, which a lot of us did 8th, some of us 9th grade. And so you can do this. It's not tricky. All right, let's go on to another one. Here, it's asking us how many liters. Okay, so we're going to be solving for liters given 0.75 molarity Na2CO3 with 0.5 moles of Na2CO3. And so here we have molarity is equal to moles over liters. We're going to be solving for liters. Remember, how do you solve for something? You have to get it by itself. And so to do that, we basically want to have this guy just by itself up top. And so to do that, we're going to multiply by liters on both sides. And so then we're going to get liters times molarity is equal to moles. And then if we divide both sides by molarity to get rid of this, to have liters by itself, then we'll have liters is equal to moles divided by molarity. Okay, so do some algebraic manipulation, whichever way you prefer, to get an equation with just liters that tells us what liters is equal to. And so here we have it, liters is equal to moles divided by molarity. Therefore, liters is equal to 0.5, right, divided by 0.75. And so liters is equal to 0.666 moles of, what is this, Na2CO3 per, oh, sorry, actually, I was just on autopilot, right? This isn't molarity, right? And so what is our unit for liters? Well, if we did it up here, right, which is always good to actually be asking yourself what you're doing. Here, if we put in our units, right, this is moles, and then molarity is moles over liters, right? And so moles are going to cancel, and the unit for liters, obviously, is liters. So we have 0.66 liters of solution, or it's actually liters of water. So liters of water. And there you go. Now, technically, if I'm doing sig figs, 2, 1, so actually this should just be 0.7. So there you go. All right, let's do one more. This time it's asking for grams. Okay, so we're trying to get grams, and it gives you milliliters and molarity. Now, you might be taking a look at this equation and saying, well, that sucks because we don't have grams anywhere. But you know, right, that if we have moles, then we can convert to grams with that thing, molar mass, right? And so, thank goodness we spent a good week doing that, right? So an entire unit. So we remember that, and if you need help, go back to Unit 6 and take a look at those videos. But so here we're going to solve for moles, and to do that, we're going to get moles by itself. So we're going to multiply by liters on both sides, so we get rid of those liters. Liters times molarity is equal to moles. Nice. Then remember, convert this to liters first. So this is going to be 0.2 liters, 2.5 molarity. Is equal to moles. Plug that in. And we get 0.5 moles of sodium bicarbonate. Or sorry, it's just sodium carbonate. I was thinking about our lab with sodium bicarbonate that we did the other day. NaCO3 minus 2, so this should be Na2CO3. There you go. So that's moles. Now remember, we got to go from moles to grams. And so we are going to put it here, 0.5 moles of Na2CO3 times, what's the molar mass of Na2CO3? Let me look at my periodic table really quick. If I'm wrong, I apologize, but let's go off of 106. And so 106 grams of Na2CO3 per 1 mole of Na2CO3. We do that multiplication times half, and so we get 53 grams of Na2CO3. And there you go. That's how many grams of sodium carbonate you would need to make 200 milliliters of a 2.5 molarity solution. So the rest are kind of similar. Let's see, any things that are tricky here? Not really. Concentration is molarity. Okay, so do note that. But yeah, no, otherwise it seems to be pretty simple, just like we did up here. Now do note that for the test, you're going to need to be able to do this for an actual solution and then be able to do it in front of me, okay? Like make the actual molarity solution, whatever, you know, is asked of you. And so make sure you know how to do it like kind of tangibly, right? Remember we did that little activity with creating solutions on Thursday, and then there were some extras that you could do on the back. And so take a look at those. Make sure you're comfortable with that. Make sure you're comfortable with this idea of creating a certain molarity solution. And that's about it. Hope this helped. Let me know if you have any questions.